If you've recently watched Jordan Peele's Nope, then this video is not for you. From flying saucers to giant floating skulls, people see weird and wonderful images in the clouds every day. We've all done it, lying down in the backyard, looking at clouds and trying to find shapes within them. But these clouds take it to a whole new level. Welcome back to the channel. In this video, we're taking a look at some of the most bizarre cloud formations captured around the world. Without further ado, let's get into it. Number 10. Lenticular clouds. As their name suggests, lenticular clouds are lens-shaped and are most commonly compared to stacks of pancakes or flying saucers. They're formed when high winds come into contact with a tall structure, like a skyscraper or a mountain, causing the air to be diverted up and over said structure. As it rises, the air cools, and if it contains any moisture, it will condense into a flat cloud formation at the crest of the wave. While most lenticular clouds appear to be hovering completely still right above the peak of a mountain, they're constantly in motion. As the air dries out and progresses downward, it warms up, while the wind steadily refills the cloud with newly condensed air from the other side. Straight shooting winds that hit an obstacle won't immediately return to its straight path once it clears the hurdle. Instead, the air will continue to move in waves on the other side of the obstacle. Lenticular clouds generally form at the crest of these waves, explaining why they often appear to be suspended above nothing. So next time you think you're seeing an alien UFO hiding in a stationary cloud, remember that it's probably just a lenticular cloud. Probably. Number 9. Fall streak holes. The sky is falling! Or maybe it's just a fall streak hole, a type of cloud formation that looks like there's a piece missing from our sky. The reason these formations are sometimes called hole punch clouds is because, well, it looks like someone used a massive hole puncher on a cloud. To create a fall streak hole, you'll need a layer of medium or high altitude clouds that contain supercooled droplets. While these droplets exist at below freezing temperatures, the lack of anything solid for them to form ice around keeps them in a liquid state. Introduce something solid to these supercooled droplets, like ice crystals falling from a plane overhead, and all of said droplets will freeze and fall, leaving a hole in their wake. Thus, we're left with a massive gap in the clouds revealing the sky above. Like many of the other cloud formations on this list, fall streak holes are often thought to be the result of an alien spacecraft entering Earth's atmosphere. We're here to reassure you that that's definitely not what's happening. Number 8. Kelvin-Helmholtz cloud. Try saying that 5 times fast. It's no coincidence that these clouds, which are named after Lord Kelvin and Hermann von Helmholtz, who studied the physics behind these clouds, resemble certain ocean waves. Both these clouds and the ocean waves that they resemble are formed when the top layer of a substance moves at a quicker rate than the bottom layer. When the upper layer of the clouds is warmer than its lower layer, it becomes less dense, allowing it to move faster than the colder, denser cloud below. This creates an instability at the boundary between these two layers, causing the top edge of the lower layer to rise, moving faster until it curls over, much like the way an ocean wave breaks. If you're on a flight and you hear the pilot mention a Kelvin-Helmholtz cloud over the intercom, prepare for some mild turbulence. Number 7. Roll clouds. If you ever get the chance to see one of these rare cloud formations in person, you're likely to be extremely confused. Roll clouds are low, long, tubular Arcus clouds that can extend for hundreds of miles. Similar to Kelvin-Helmholtz clouds, they are formed by the interaction between the warm air on top of cooler air. This is known as an inversion, and is what causes the instability that eventually creates these clouds. In the case of roll clouds, the inversion is usually caused by a thunderstorm. Roll clouds are unbelievably rare, and the only place that produces them with any measure of consistency is Cape York in Australia. Down under they call roll clouds morning glory clouds. They also don't necessarily always coincide with storms. As for why they are so consistent in Australia and nowhere else, scientists and meteorologists are still unsure. It's believed that it has to do with a regular collision of the sea breeze moving across the Cape, from the Gulf of Carpentaria, and the sea breeze moving west from the Coral Sea. So if you ever want to see what is truly one of the most awe-inspiring and bizarre cloud formations out there, consider paying the land down under a visit. Number 6. Anvil cloud. These clouds are aptly named. We're sure you can see why. When a thunderstorm brews, air currents known as updrafts rise up high into the air, cool down, and begin to form clouds. However, there is a particular point in the atmosphere between the stratosphere and the troposphere known as the tropopause, where the air no longer cools down with altitude. If an updraft is moving quick enough to reach the tropopause, it won't be able to move any higher. Instead, it will begin to move laterally or horizontally. As a result, it will form a flat-topped cloud known as cumulonimbus incus, or an anvil cloud. They're named as such because they look like massive anvils made of cotton candy floating in the sky. Sometimes an updraft will be so strong that it shoots up straight past the tropopause and into the stratosphere. In this case, a cloud formation known as an overshooting top, yet another apt name, will appear above the flat surface of the anvil cloud. While this is certainly a majestic cloud formation, if you're seeing one, you'll need to prepare yourself for a truly formidable storm. Number 5. Asperitas cloud. Gavin Pretopini, founder of the Cloud Appreciation Society, suggested that the World Meteorological Organization add a new designation to its International Cloud Atlas. This new description was one of billowing, tumultuous cloud waves that lack an obvious pattern. And it wasn't until a decade later that the organization finally complied, tweaking the name that Pretopini originally proposed, Asperitas. That's Latin for roughened, and the WMO decided to opt for the noun form of the word, asperitas, or roughness. Naming conventions aside, asperitas clouds are formed when lateral, stable clouds that stretch at low to middle altitudes are disrupted from multiple directions. This is often caused by a brewing storm, which results in their signature dark appearance. Here's an analogy to explain the formation. Imagine you're cannonballing into a pool. Once you hit the water and splash, the waves radiate outward in circles. The same thing happens to local pockets of air moving up or down in the atmosphere, inducing gravity waves. This happens a lot during thunderstorms. If several people jumped into the pool at the same time, turbulent wave-like motions would cause the surface of the water to become quite chaotic. A similar phenomenon happens in the sky, which causes asperitas clouds. Number 4. NACREOUS clouds. If you take a trip to the Arctic and happen to miss the northern lights, the next best thing you might see are NACREOUS clouds, also called mother-of-pearl clouds. These are a kind of polar stratospheric cloud which gets their name from the fact that they form in the stratosphere when temperatures drop well below freezing. In the case of NACREOUS clouds, that means temperatures of around minus 180 degrees Fahrenheit or colder. That's why they're generally only seen in the Arctic and Antarctic regions of the world. The ice crystals in the NACREOUS clouds diffract or scatter light waves that creates a beautiful, mesmerizing display of colors throughout the sky. While they're certainly stunning to look at, they spell bad news for the environment. Research has proven that polar stratospheric clouds activate certain chlorine compounds, such as chlorofluorocarbon. This chemical is a man-made greenhouse gas often used in aerosols, refrigerants, and cleaning solutions. To put it simply, this chlorine destroys the ozone layer, which happens to form part of the stratosphere. So, remember that if you're ever seeing NACREOUS clouds, you're also watching the ozone layer actively tear apart. Dark stuff. Number 3. MAMMATUS clouds. As with many of the other clouds we've already mentioned, MAMMATUS clouds require an unstable atmosphere, which is why they often appear around stormy weather. Meteorologists are still unsure of the exact details of why MAMMATUS clouds form, though some scientists believe that the process involves sublimation, when ice directly turns into water vapor without moving through the liquid stage. The leading theory states that ice crystals form when a cloud turns into vapor, cooling down the surrounding air and therefore making it denser. This colder, denser air starts to sink in pockets, resulting in the appearance of MAMMATUS clouds. While you'll generally only see these clouds beneath a storm cloud following some pretty harsh weather, MAMMATUS clouds can also form from fair weather clouds, like altocumulus or cirrus, though this is a much rarer occurrence. Number 2. Mushroom clouds. Okay, maybe this one is cheating, but mushroom clouds are still clouds. They're the only non-natural clouds featured on this list, since they're the product of incredibly powerful explosions rather than rare meteorological events. Aptly named, these mushroom-shaped clouds generally carry vast amounts of smoke, debris, and water vapor from explosions that do not occur naturally without human interference. This also makes them one of the rarest clouds in the world, thank goodness. These clouds are most often related to nuclear detonations, but they can also occur from volcanic eruptions. Mushroom clouds form as a result of the sudden formation of large masses of hot gas that rapidly rises in the air without having any other place to go, circling around the edges in a mushroom-shaped formation. No matter how they're caused, if you see a mushroom cloud, you're likely going to hear an extremely loud bang not too long after. Number 1. Funnel clouds. Most often seen in the United Kingdom, funnel clouds are Mother Nature's way of playing a prank on humanity. They're often mistaken for tornadoes thanks to their column or funnel-like shape. Funnel clouds are made up of condensed water in rotating wind funnels, though the main difference between them and tornadoes is that funnel clouds don't reach the ground, instead opting to stay airborne. While they aren't tornadoes themselves, funnel clouds can signal the onset of a tornado if they do manage to reach the ground, as they tend to gain more strength and speed as they move. They also form the same way that tornadoes do, with wind picking up in a cone-like formation. They also spin just like tornadoes, so if you're ever worried that you're actively watching a tornado form, wait and see if it touches the ground. If it doesn't, great! You've just seen a rare cloud formation that is the funnel cloud. If it does, well, get under cover. That's a tornado. And that's a wrap, folks. Now it's time for a fun fact. This time about lenticular clouds, the flying saucer-shaped clouds mentioned earlier in the video. While aircraft pilots try to avoid lenticular clouds, as they do with most other cloud formations, glider pilots actively love them. They use them to remain airborne, being propelled by the rising air currents that help them to climb upward along the moving air. Which of these cloud formations was your favorite? Let us know in the comments. If you liked the video, don't forget to hit the thumbs up button down below and subscribe to the channel. Until next time, goodbye.